Today, we're going to solve a classic limit problem involving square roots. The limit as x approaches positive infinity of the square root of x squared plus x minus x. This is a common indeterminate form that students often struggle with, so let's explore both a common mistake and the correct approach. Many students, when they first see this problem, try to approach it by simply pulling x out of the square root. They might write the square root of x squared plus x equals x times the square root of 1 plus 1 over x. Then they substitute this back into the limit, getting x times the square root of 1 plus 1 over x minus x. As x approaches infinity, they reason that 1 over x approaches 0, so the square root of 1 plus 0 is just 1. Therefore, they conclude the limit is x times 1 minus x, which equals 0. But wait, this approach contains a critical error. When we factor out x from the square root, we must be careful about the sign. The square root of x squared is not simply x, it's the absolute value of x. Since we're taking the limit as x approaches positive infinity, where x is positive, we can say the square root of x squared equals x. However, the simplification x times the square root of 1 plus 1 over x minus x still leads to the indeterminate form infinity minus infinity, which we cannot evaluate this way. So this method, while it might seem intuitive, doesn't give us the correct answer. The limit is actually not 0. To solve this correctly, we need to use a technique called rationalization, or multiplying by the conjugate. We take our expression, the square root of x squared plus x minus x, and multiply both the numerator and denominator by the conjugate, which is the square root of x squared plus x plus x. When we multiply out the numerator, we use the difference of squares formula, a minus b times a plus b equals a squared minus b squared. So the numerator becomes x squared plus x minus x squared, which simplifies to just x. The denominator is the square root of x squared plus x plus x. Now we have the fraction x over the square root of x squared plus x plus x. Next, we factor out x from both the numerator and denominator. In the denominator, we can factor x out of the square root by writing it as x times the square root of 1 plus 1 over x. So the denominator becomes x times the quantity, the square root of 1 plus 1 over x plus 1. Now we can cancel the x in the numerator with the x in the denominator, leaving us with 1 over the square root of 1 plus 1 over x plus 1. As x approaches infinity, 1 over x approaches 0. So the square root of 1 plus 0 equals 1, and we get 1 over 1 plus 1, which equals 1 over 2. Therefore, the limit as x approaches positive infinity of the square root of x squared plus x minus x equals 1/2. The key insight is that rationalization helps us transform an indeterminate form into something we can evaluate. Remember, when dealing with square roots and limits at infinity, always consider using the conjugate technique. It's a powerful tool that reveals the true behavior of the function.